Welcome to the ET335 741 Op Amp Lab. Okay, we're at Multisim and let's build our op amp. So let's go to analog, grab a 741. Let's go to power sources, basic sources. Let's grab a VCC. Let's grab a VEE. We're going to need a ground. And we're going to need some resistors. So let's go to basic. And I believe we need 100K. Whoops. Resistor. I think we need a 1K. I think we're going to use 100K. And I think we're going to use a 51. I think that's a good start for now. So first thing let's do is let's make these 12 and minus 12. And let's flip this one vertically so we get our minus on top. Okay, let's distribute our components. So we're going to put the 100K on top. 51K in on our input. Oops, and for some reason this guy got unflipped. So we want to flip him where we have the minus on top. And our 1K is going to be our output, and we're going to need a ground. And we're going to need a ground on our non-inverting input. Our 51K goes in, and we're going to have that above there, and we have our VEE minus pin 4 and our VCC to 7, and let's flip him vertically so we could get a good connection. Alrighty, so let's connect our ground. Let's connect our minus power supply, our output resistor, and our feedback resistor. Okay, that looks good for. Okay, we need to add a scope and we need to add a signal source, and we want AC. And we're going to need a ground. And let's connect him to our input resistor. Let's open this up, and I believe he's 5K. And he is 1 volt peak to peak. So 1 volt peak to peak will be 1 volt peak to peak. 6.5. Peak should be 1.5 peak to peak. Let's grab our Tektronix. Let's grab a ground. And let's go to our input, channel A, and our output, channel B, and we want to go on this side of the resistor, not ground. Good, so let's fire it up. Adjust our scope. On. Spread our timing out. And we are, let's go to 0.5 volt. And let's turn on our blue channel. Keep them both the same. Actually, let's make this 1 volt. And this guy 1 volt. And let's spread it a little more. And do a single, and we captured it. So what we have here is gain of 2, 51 into 100, and we're out of phase, which is right for an inverting op amp. So this is good. Here's our output waveform again, and again we have a gain of 2, and we're 180 degrees out, which is correct for an inverting amplifier. The next part of the lab requested us to increase the input voltage, which I did. I went it up to 18 volts to peak, and we have plus and minus 12 volts. So here I'm showing the clipping that happens because we overdrove it, and this level and this level are based on our power supply. This device can't put out more than what we give it to power it. Okay, here it's asked us to measure at point A and B. B is ground. A would be our virtual ground point. So these two are going to be at the same potential. So the virtual ground, we should not get a reading other than noise at that point because of the virtual ground phenomenon. So they should be the same, and that's the output we're going to get. Okay, here's a close-up of our virtual ground display. And here's our ground, and this is our virtual ground. So we're just going to see noise. We're not going to measure any voltage on that. If we do, then we have a problem with our circuit. Okay, next thing it asks us to do is cut between B and C. So what this is going to do is this is going to destroy our feedback, and we're going to get a clip signal at A. B will be the same clip signal, and C should be our input waveform. So let's try it. Okay, here I broke the connection between our feedback resistor and our input. So at point A, we're going to get a clip signal. Okay, we have no feedback, so we're going to drive this to our maximum. So we're almost at our power supply voltage. Okay, at C, which would be our cyan here, we're getting our 1 volt input. So we're getting our input voltage here, since there's no feedback, no virtual ground. And at our output here, or before the feedback resistor, we're getting the same voltage as our output, since it's essentially the same circuit. Okay, here's a closer view of our waveforms on our oscilloscope. And here we see what happens when we have our feedback resistor cut. So both the output and one end of our feedback resistor are going to be clipped. So we're going to be clipped at close to our power voltage. And at the other input, we're going to see the input wave signal. So here's our 1 volt peak to peak. And that's what happens when our resistor is cut. Okay, the next thing it wants us to do is cut our feedback resistor on this side. So what we're going to end up with is this is going to be a large clip signal because we have no feedback. Over here, we're going to get the input signal, and over here, we're going to get the input signal. So anytime we have a cut, we're going to get the same signal on both sides. And here I've cut our feedback resistor between the output and our feedback resistor. And our output again is going to be a large clip signal since we have no feedback gain. And we're going to receive the same signal, our input signal, on both sides of our feedback resistor. Okay, the last thing it wants us to do is cut between our resistors and our op amp. So what's going to happen is that our signal is going to be the same through this. Since there's no input, we're just going to get the input signal in all these locations. So let's try and see if I'm correct. Okay, here we've cut between two in our feedback resistors, and we see that our output is at the rail. Since this is cut, we became a comparator. So we're comparing to ground. It drove it to the positive rail, and that's our 12-volt rail. Here we have our input signal of 1 volt, and it is writing on a DC of 4.5. So, okay, we have our input signal writing on what appears to be about 4-volt DC. And where does that come from? I went back and did a little calculation here, and right here we have 12 volts. Here we have a voltage divider. So 51, we're going to consider that going to ground. So 51 divided by 151 divided by 12, or excuse me, multiplied by 12, it's going to get us about 4 volts. So that's where that DC bias came in from.